Keeper 4.4, using known series to find Maclaurin series. Alright, so in the previous lesson, I asked you guys to memorize a few of your basic Maclaurin series. I'm hoping at this point you guys do have memorized, but just as a refresher, we need to memorize 1 over 1 minus x is x to the n, 1 over 1 plus x is negative 1 to the n x to the n, e to the x is x to the n over n factorial, ln 1 plus x is negative 1 to the n x to the n plus 1 over n plus 1. Sine x is negative 1 to the n x to the 2n plus 1 over 2n plus 1 factorial. Cosine of x is negative 1 to the n x to the 2n over 2n factorial. And then tan inverse of x is negative 1 to the n x to the 2n plus 1 over 2n plus 1. And again, we're going to use this stuff that we memorized to build other series. So again, it's so super important that you have these things memorized and know them like the back of your hand. All right, so example 1, it says find the Maclaurin series for f of x equals e to the negative x. And so what you want to do is you want to start with one of the ones that you have memorized. So obviously the one that we would start with in this case is e to the x. And we know that e to the x equals the sum from n goes from 0 to infinity of x to the n over n factorial. And so now I'm going to build my series from this one. And so instead of e to the x, I'm going to do e to the negative x, which tells me that everywhere I see an x, I'm going to put negative x. And so in my summation, I'm going to have the summation from n equals 0 to infinity of negative x to the n over n factorial. Technically, at this point, I'm done. But again, I like for everything to have its own separate, every base to have its own exponent. And so I'm going to rewrite that as negative 1 to the n, x to the n over n factorial, the summation of that whole thing. All right, so the next example, we have f of x equals x to the 4th times e to the negative 3x squared. Again, I'm going to start with one of my known, which would be e to the x. And I'm going to build my series from there. So I'm going to, instead of e to the x, I'm going to do e to the negative 3x squared, meaning everywhere I see x, I'm going to put negative 3x squared. And then I'm going to multiply the whole thing by x to the 4th. So I'm going to end up with the summation as n goes from 0 to infinity of negative 3x squared to the n times x to the 4th over n factorial. And then I'm going to separate everything out to make it look like a power series. And so I'm going to have negative 1 to the n times 3 to the n times x to the 2n plus 4 all over n factorial. Alright, so example 3, it says find the Maclaurin series for f of x equals cosine 4x. Again, I'm starting with something that I know. I'm starting with just my plain old cosine summation. And then I'm going to replace that x with 4x. And so everywhere I see x in my summation, I'm going to put 4x. And then I'm going to write this out so that each one has its own exponent. So I have negative 1 to the n, 4 to the 2n, x to the 2n over 2n factorial. Alright, now I can even write this a little bit better. Instead of writing 4 to the 2n, I can change that 4 to be 16 to the n, and it looks a little bit better. Example 4 says find the Maclaurin series for f of x equals ln of 3 plus 4x. First thing I'm going to do is I'm going to rewrite this. And so for ln of 3 plus 4x, I'm going to pull out the 3 to be ln of 3 times 1 plus 4x over 3. And then I'm going to use my log rules. So instead of ln 3 times whatever, I'm going to say ln 3 plus ln of 1 plus 4x over 3. And the reason I did that is because my known series that I want to start with is ln of 1 plus x. So I needed that 1 there, and that's why I had to factor out the 3. So if I started with my known of ln of 1 plus x, I can build it by changing that x to be 4x over 3. So that means in my summation, everywhere I see an x, I'm going to put 4x plus 3. Alright, so then I'm going to rewrite it to clean it up, make it look more like a power series. So I'm going to have negative 1 to the n times 4 to the n plus 1 times x to the n plus 1 over 3 to the n plus 1 times n plus 1. And so then my very last step would be to add the ln of 3 to both sides, or to my equation, to get my original, or what I was trying to find. So I have ln of 3 plus the summation as n goes from 0 to infinity of negative 1 to the n, 4 to the n plus 1, x to the n plus 1 over 3 to the n plus 1 over n plus 1.